The early universe. Cosmologists know that the universe is expanding now, and extrapolate this expansion backwards in time in order to study what the early universe was like. About 13.75 billion years ago, all of the contents and energy in the universe was contained in a singularity with infinite density and temperature. It began to expand rapidly, and this expansion is known as the Big Bang. The laws of physics as we know them did not apply during the early seconds of the universe, and scientists can only speculate about what the early universe was like. 13.75 billion years ago, the Big Bang. It is not known what triggered the Big Bang. Cosmologists believe a process called inflation happened in the fraction of a second after the Big Bang. There was a strange type of vacuum energy that caused the universe, the volume of space itself, to expand by a factor of 10 to the power of 78 in a fraction of a second. 1 second after the Big Bang, the universe was made up of fundamental particles including quarks, electrons, photons and neutrinos. The universe continued to expand, but not as quickly as during inflation. As the universe cooled, the four fundamental forces in nature emerged: gravity, the strong force, the weak force and the electromagnetic force. Protons and neutrons began to form. The temperature of the universe was around 10 to the power of 32 Kelvin. 3 minutes after the Big Bang, protons and neutrons began to come together to form the nuclei of simple elements. The temperature of the universe was still incredibly high at about 10 to the power of 9 Kelvin. 24,000 years after the Big Bang, for the first time there was more matter than energy in the universe. 380,000 years after the Big Bang, the temperature of the universe had cooled to about 3,000 K. Electrons began to combine with hydrogen and helium nuclei. High-energy photons from this period rushed outwards. The early universe was so hot, that as it has expanded and cooled, the highly energetic photons from that time have had their wavelengths stretched tremendously. The cosmic microwave background we observe today is evidence of what the early universe was like. The temperature of the cosmic microwave background is now only a few degrees above absolute zero, and radiation left over from this period has wavelengths of about 1 mm, which is in the microwave range of the electromagnetic spectrum. This cosmic microwave radiation is what astronomers study with telescopes like Planck and others. 1 billion years after the Big Bang, the pull of gravity began to amplify irregularities in the gas in the universe. As the universe expanded, pockets of gas became more dense and stars began to ignite. Groups of these stars became early galaxies. Many of these stars were much larger than the most common stars today. 3 billion years after the Big Bang, many small galaxies merged to form larger ones. Often these mergers were so violent that the stars and gas collapsed and formed black holes. The gas flowing into these black holes became hot and glowed brightly before it disappeared into these black holes. This light was bright enough that it can be seen across the universe. These bright lights are called quasars. 6 billion years after the Big Bang, large, short-lived stars ended their lives in supernova explosions that distributed heavy elements such as nickel, gold, silver, and lead into the universe. 8 billion years after the Big Bang, our Sun and Solar System began from a cloud of dust and gas in a spiral arm of the Milky Way galaxy. 9,200 million years after the Big Bang, about 4,500 million years ago, the Earth formed. 13,750 million years after the Big Bang now. For more video like this, visit and subscribe our channel.